Okay, shh. So I'll just do some quick review here. Let me put, if I had 0.2 times, let's say 0.7, and 7 columns, so 1, 2, 3, 4, 5, 6, 7, 2 times 7, if I was to write 0.2 times 14, but there's 2 decimals, and so it's actually 14 is the answer. And
Is a question about the decimals. So when you have to move it 2 places, why do you always start at the end?
I start at the end over here, like at 14, I start right here, and then we move it over left. Then we move down over here. If I had, let's say, a number 2.37, and multiply by 3.6, okay. How many times move the decimals to get all the way back to 1, 2, 3? So decimals, you have to count how many places you have to move them to the right. And so it was 3 places. So my answer, I don't know, I'm not going to do the problem, but let's say that was my answer. I didn't count 1, 2, 3, so it would be x increases. So you have all the way to the right, and the right would be less. Okay, so let's say 5 times 0.3. First, I could do 0.5 times 0.3. 3 to 5, you know, is 15. It's really a fraction, 15 over 100. But let's see what it would look like. So I'm going to color half of these in. 1, 2, 3, 4, 5. And then 0.3 of them, I'll color those. Now I'm going to go up and down. A little bit harder to see. I mean, you still can see the overlap area is right there. So we know what the answer is. How many squares are we going to find in there? 15. If we counted them, there'd be 15 squares in there. I'm going to give you one more example, and we did one like this the other day. And so let's say this one, it's not just 2 single-digit decimals. One of them, let's say it's 0.3 times, how about 1.2? Okay? So again, I could put 1.2 here. I'm going to multiply that by 0.3. And 3 times 2 is 6. 3 times 1 is 3. 2 decimal places. I'm going to start here, move it over 2 places. So the answer is 0.36. So that should tell us that, what, we're going to have probably 36 squares if we do it right. So I'll do the 0.3 first, and I'm just going to go close. 3 continued. 0.3. Now I'm going to do 1.2. Okay? And so I'm going to do a whole 1.2. Yeah, it looks kind of more purplish. So here's the how many squares do you think are? Yeah, there's going to be 36 if we counted them. Okay? So I'm going to give you guys a handout, and the problems are very similar to these that we just did. And there's one more thing I want to show you, just so you don't get confused. I'm going to make up one more problem, and I'm just going to, it'll be a simple one. How about 0.2 times 0.5? Okay? So 0.2 times 0.5, you know the answer, 2 times 5 is 10. 2 decimal places, 1, 2. So the answer is going to be 1, or if we put 1.0, it's the same thing. So how many squares we'll have in our model that are going to overlap? Now look, watch what happens here. I'm going to do 2, and then I'm going to do 5. I'll just use the same color because it'll get darker. But look, you can see that there's 10, okay? So That's the way I've taught you to do it, where you go from left to right. But what if I did the point 2 going, instead of left to right, what if I went down first? And I did half of them going left to right first. Opposite. There. Yeah, the same. So I just showed you that to let you know that if you actually start a problem, instead of going left to right first, you go up and down first, that's okay. It doesn't matter. And lastly, one of the problems you'll have to do is just like this one, different numbers, but it's very similar. Remember, this is considered one whole square. So if you've got to do 0.3, you would go all the way across. You wouldn't just do a third here. You would go all the way across. Okay? Right, yeah, because there's 2 together there. There's 2 squares. All right? So I'm going to end this video.